Now, a lot of chapter 12 is going to be reading. So let me go to chapter 12. And let me tell you what's going to be pretty much reading. This whole first section is going to be reading. All right, write down 11.1 or 12.1 is reading. Yeah, and 12.3 we'll get into. Okay, I know what we're going to do now. So I want you all, I'm going to pick out the high points of 12.1. And I want you to write down everything that I talk about, because you're responsible for it technically on a test. Although on this test, I'll probably not pull a lot out of 12.1. I'll just maybe one or two questions. Make sure you know what the definition of statistics is. Now, there's two definitions of statistics. Capital S, statistics, is the study and interpretation of data. Okay? Gathering, calculation, and interpreting data. Population, that is the big group. A sample is a small group. So if I wanted to find out for all of Tri-County Technical students, that means what? Pendleton campus, Easley campus, Oconee campus, Anderson campus, the campus down we have in BHP or Honey Path, business campus, any campus that teaches Tri-County Tech, the one in Sandy Springs. We've got all kinds of different campuses. That's the population. The population would be Tri-County Tech students. The sample would be Anderson campus. So if I wanted to find out how many people were in the Marlboro Club at Tri-County Tech, then the population would be Tri-County Tech, and the sample would be Anderson campus. And I would do all my research on the Anderson campus. Now, why would I do all my research on the Anderson campus and not do all the campuses? That's the question I'm asking y'all. So that means y'all can talk. Why would I do Anderson campus? Why wouldn't I just go over and do all the campuses? Too much what? Two things that are most important to us. Too much time and too much money. Now, you got to think. You're talking about a company doing this, or you're talking about, your quality assurance. Time is what? Time is money. So if you're working for somebody and they tell you they want you to go out and do this, you're going to take time and you're going to take money. So which is quicker, to do the statistics on the Anderson campus or do the statistics on all the campuses? The Anderson campus. And then the interesting part about statistics and probability is to find out how reliable the Anderson campus predicts for the whole campus. Okay? So if I get 10% or 20%, no, it could be more than that. It'd be like 30% that are in the Marlboro Club. 30% is that a good number for the Pendleton campus? And then you have to do some deeper mathematics or deeper statistics to get what's called a confidence level. And that's later on. But anyway, that's what a sample and a population are. That's what they are. So make sure you know those three things. Make sure you know what the word bias means. If I was to ask you the definition of bias, what would you tell me? Huh? One-sided opinion. Yes, very much. Where do you hear the word biased a lot these days? Politics. You hear it a lot. They have found machines in Texas that if a person hits, you can vote all Republican, right, or all Democrat. You can just hit a Democrat button and a Republican button, and it'll pick all the Democrat and all the Republicans. You know that, right? Okay, still not going to answer. Well, in Texas, this happened in 3 different counties in Texas. The people were hitting Republican, the Republican button, and it was voting all Republicans except for what? Except for the president, and it was hitting Clinton. And people had to go back and get a paper ballot because they couldn't fix it. Now this has happened with early voting, and they're having to do paper ballots in Texas because they can't fix it. I just wonder how many people have early voted and didn't check. Make sure you check your vote, okay? Because this is, I'm not talking about 3 people, I'm talking about 3 counties. We're finding this out. And it could happen in South Carolina just as good because we don't know where these machines are coming from. So check your vote. But bias. Bias means that you're leaning to one side. Can a person ask you a question in a biased form? Yes. They can say, do you think the taxes are outrageous in Anderson? Well, that's a leading question. Why is it leading? Because you're already setting up the question for a negative response. Do you think the taxes in Anderson are outrageous? Okay, you're leading the person. The more neutral would be, how do you feel about taxes in Anderson? Normal, crazy, not enough, or whatever. That's the type of question you ask. You don't say, do you think the teacher in 155 is awful? That is a bad question. You don't ask questions like that. Okay? Not being politically correct. That's not what I'm talking about. When you put a negative spin on a question, it's going to excite the negative sense in a person responding. Negative excites negative. If you don't believe me, go to a hair salon or the fire department and find out how quick gossip takes. How quick does gossip take? All you have to do is mention one thing, and oh my gosh, it starts. All right, negative begets negative, and positive begets. You could say, "Don't you think Donald Trump is a great, and that would be a leading question. Or don't you think Hillary Clinton is a great president? Yes, or great presidential candidate, because you're leading, you're biasing the question to be positive. Now, what about presentation of statistics? Yes, it could also be biased. They're going to show you some examples of they're called pictographs. You ever seen an oil barrel? You ever seen an oil barrel on a graph and then have a little oil barrel and another little one, or whatever? Those are called pictographs, and those are highly inaccurate unless they're scaled exactly the way they're supposed to be scaled. Yes, kind of, yeah, they're kind of like that, yes. And if they don't scale them perfectly, the common person that's reading or watching it, whether it be on a video or whether it be, they're going to get a negative connotation to that pictograph. So yes, statistics can be, and that's why it's so, right now, this morning, and this is newsworthy. I'm sorry that we are electing a president, okay? Every election I've ever been in, people get excited, whether it's negative or whether it's positive. There is no way to avoid there is an election going on. There is no way for a math teacher not to talk about an election, okay? I'm sorry, I'm talking about it. But right now, there is news going on right now in the news that several of the polls that are being taken, guess who they're asking? They're asking Democrats. Well, guess who the Democrats are going to vote for? So the polls are biased. Not all. I didn't say all. I said some, because the report that I was looking at this morning, it was saying that several, probably 3 out of 15 polls. So they're not talking about all the polls. They were saying 3 or 4. Now, why would you bias the polls? Why? Say again? Exactly. That makes, if you've got a poll, if you've got a, I don't, how do I say this? What do you call a voter that's not as educated as other voters? What do you call that? Okay. All right. You said it. But you got these voters that just watch the TV, and if the TV said vote for Mickey Mouse, guess what that voter would do? That voter would go down and say, where's the ballot for Mickey Mouse? You have voters that unknowledgeable. How about that? Now, how much of the population are you talking about? 10, 15%. But if, like you said, if you put enough of these polls up, those 10 or 15% voters are going to see, oh, well, Hillary's winning, so I might as well do what? Vote for Hillary. Personally, I don't think they should put any polls up. I don't think they should put any polls up. I think they should cover the election, but I don't think they should put any polls up. I don't think, if it's not having to do with the election, if it's not having to do with policy, I don't think they should talk about anything like that, because that sways voters. And I really don't, that's just my own personal opinion. But biasing, that is a bad thing in statistics. Make sure you know these samples. Systematic sample. A random sample, let me explain a random sample. That's on the previous page. Random sample is a test question. If I take everybody's name and I put everybody's name on a piece of paper, a Post-it note, because Post-it notes are all the same what? Size and color, Hubert. That's right, class. Thank you for the interaction. They're all the same what? Size. So I could fold it in half and they'd all be the same what? Size. And I take all your names and I put your first and your last name, I fold it in half and I put it in a fishbowl. And I say, I'm going to pick out one person, I'm going to give them a $100 bill to the person I pull out of this fishbowl. That is a random sample. Why? There's no method to picking it. Everybody has the same one. Okay, that is the definition of a random sample. Every participant has the same chance. You need to write that down, because that's how you keep it in your brain. And I don't know what they define it as, but that's a random sample, where every participant has the same chance to be picked. So anytime you put names in a fishbowl, ping pong balls in a fishbowl, anything drawing out of a fishbowl. Now, what if I decided to fold 2 or 3 of those Post-it notes differently? Would that change it? Yes, it would. Each piece of paper has to be folded the same way. Each piece of paper should be the same size. Each piece of paper should be the same color. Therefore, when I reach in the bowl, I'm not led to pick something by the way it feels or the way it looks or whatever the case may be. Excuse me. A systematic sample. That could be a test question. A systematic sample would be, okay, I'm going to go through, and every third person in the class, I'm going to put their name on a post-it note, put them in a fishbowl. 1, 2, 3. And take her name and I put it in a fishbowl. 1, 2, 3. Take your name and put it in a fishbowl. 1, 2, 3. I take your name and put it on a fishbowl. You don't get nothing. So there's 3 people that has their name on a fishbowl. Now, is that a random sample? No. Is it a systematic random sample? Yes, because I picked every what? There is a what? Pattern. Okay? Pattern, systematic. Remember that. That's a test question. You're not going to get too many of these, but the test questions that I'm telling you is test question, I might put them all in one group and pull one question out of it. So you might get your number 1 may say, what is a random sample? But your number 2 may say, what is a systematic random sample? They come out of the same group. So I may pull one question out of all these definitions. I don't do cluster and stratified too much. You can write it down if you want to, but I'm not going to cover that too much. Convenient sample. This is a test question. Convenient sample would be like, let's say when I got through working at Tri-County Tech, I was a bartender at blah 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 bar, and I wanted to find out how many people liked drinking in that bar. Would that be a convenient sample? Why? Because everybody that goes into a bar does what? Drinks. If I was wondering how many people drink alcohol and I work at a bar, that's called a convenience sample. In other words, I'm asking them something about my job. I'm asking them about that in my job. So name where you work. Bilo. Let's say you work at Bilo. How many people in there like to eat? Probably a lot of them. Since they're buying food, all right, that would be a convenience sample. Think of where else you work. Name another place you work. Y'all don't work anywhere? Well, y'all just not going to talk to you. Huh? Well, I was trying to get the rest of the class to talk, but that's impossible. Movie theater. How many people in here like movies? Okay, well, if you work at a movie theater, guess what the answer is going to be? Everybody. Because you wouldn't be in a movie theater if you didn't like, I like to go to the grocery store, but I'm going to go to the movie theater tonight. Nobody ever, if you go to a movie, I love to go to the movies. I am a movie person. I love to watch movies, okay? But, you know, the convenient sample is the least valuable. Why is it the least valuable? Because it's going to be biased no matter what you ask. Depending on if you are working in this place and you're asking about this, or, you know, you can easily tie it to, if you wanted to find out how many people at your workplace smoke and you worked at a bar. What do most people do when they drink? They smoke, all right? Or if they don't smoke a lot, they smoke more when they drink, vice versa. So that convenience sample wouldn't be worth a flip because 88% of the people that come to a bar smoke. That would be way out of the norm. Okay, so that would be a convenience sample. You don't want to use a convenience sample if you're trying to prove a point. Here's misuses. Let's see what their misuses are. And I was going to see if they... Okay, here's one. Right here, look at this. Here's two examples of pictographs. They're either two-dimensional or three-dimensional. Now, somebody tell me what's wrong with these pictures. I'll blow them up for you. No, I don't need to blow them up. Y'all can see. What's wrong with those two pictures? They're inaccurate. Why are they inaccurate? Now, I'm sorry, y'all gonna have to talk. Well, it's $1 this year, and the other one's $2. So one has to be smaller. But look at these two. Compare these two. And compare these two. Why are they inaccurate? Huh? Well, that's what she said, but that's right, because one is smaller than what? 2. Then what's wrong with it, Hubert? They're not the same. Well, let me ask you this. What's the difference between 1 and 2? What is the relationship between 2 and 1? 2 is double what? 1. So the boxes should be double the size of each other, right? The $2 box should be double the what? $1 box. Is that true? Well, look at it this way. How many of these can you put into this? How many of these can you put into this? I think you can put 4 of these in this one. So this box is 4 times the size of this box, when it should be what? 2 times, or $1 more, whichever. See what I'm saying? That's how people do pictographs wrong. This one. How many of those blocks could you fit into this? Probably 1, 2, 3, 4, 5, 6, 7, 8. That box is 8 times bigger than this box. But the price is what? Just double. So that's how a pictograph can be. And that's why you have to be very careful. I'm looking for the right word. Knowledgeable. You have to be very knowledgeable, because they're depending on you to be what? Stupid. I mean, honestly, because they're trying to get a point across. A lot of times you see that when you're talking about the environment. You get a lot of statistics saying, oh, we're going to die tomorrow because of what? Global warming. We've had global warming. The Earth has been in existence for how long? I don't even want to know. How did we get along in the we're several billion years old. How did we get along in the millions with global warming? How did we get along with the 10 billion years old? How did we get along there? As the old saying goes, when your time is up, guess what? Your time is up. Nobody's going to prevent it. When the world's time is up, the world's time is up. Nobody's going to what? Prevent it. Don't even get started. But anyway, that's misleading. What's wrong with that one? Huh? Well, they have to be smaller because they are smaller, but look closely. Look at the percentages. They don't add up to 100. Anytime you're given a graph, it has to equal 100. You'd be surprised at how many people look at that. Y'all know my bonus question? 30, 30, 30 versus 20, 20, 60. I still have people putting 30, 30, 30. Huh? I know, but you got to be, remember the comedian says you got to be a really certain level of stupid. You know, some people are still doing it. I had a person ask me the other day, how do they check their grade? That's no joke. And the people turn around and look at him like he was. Now, I had one student asked me the other day, is our exam online? Okay. So you see, it's kind of yeah. There you go. Thank you. And you got to be. It's kind of like a con artist. You know how when you get streetwise, you kind of are. You know, some people aren't streetwise. Some people, you know, for instance, the jewelry store. How many of you have been to a jewelry store and the guy comes up to you and says, you know what, I love you as a customer, so I'm going to take 60% off this ring because you are terrific. You think he's really taking 60% off that ring? No. He's marked it up 200%. Okay? So let's say the ring costs $100 for him. No, let's say it costs $50 for him. He puts $100 on it, then he adds another 100. It's up 150%. So he's asking $200 for that ring. He's going to mark 60% for it because he wants it. And he takes 60% off of 200. Well, 60% off of 200 is what? Well, 10% is 20. So if you take 6, what did I say, 60%? 6 times 2 is what? $12. Or $12, I can't think. Oh, yeah, he's going to take $120 off. So you're going to pay what? $80 for that ring because he likes it. So he's making what? He's making $30 off of it. Nothing is what? Nothing's free. All right. When you go, I go. My dad, my son. I love my son to death. He just turned 10 years old. We go to the grocery store. We go down the cereal aisle. He said, "Daddy, these 2 boxes are free. Buy one, get one free." Yeah. Look how much you pay for that first box. That goes $8. You paying for the what? You paying for the second. You paying $4 a box. Nothing's free. All right. So that's what you get right here. Just be careful. Always look. Because chances are, if it looks like a duck, and it walks like a duck, and it squawks like a duck, chances are it's a duck. And if it looks bad, smells bad, guess what? It's probably bad. You probably need to step away from it. Aren't y'all glad y'all learned so much math in this class? Frequency distribution. Okay. What is a frequency distribution? A frequency distribution is a 25-cent word for a chart. Okay, write that down. Frequency distribution is a 25-cent word for a chart. You see these numbers right here? Well, you can put those numbers in a chart form. And it looks something like that. And this is what you call a frequency distribution. I call it a head count. We can make a frequency distribution with this class. Let's go in here and really blondes, brunettes, and redheads. Okay? Blondes. I'm just going to go through the room. Looks like we've got what? Maybe 2 blondes. I'm not even going to look at anybody. 2 blondes. I think everybody else is brunette. Yeah, I think everybody's brunette. I don't see redhead. Where's redhead? Anybody got redhead? Okay, so rest. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 8 are brunettes. Means dark DA hair. Dark attitude hair. And 0. That is a frequency distribution. A frequency distribution is nothing but a what? A head count or a chart. So don't get confused by such a BA title, because all it is a chart or a table or a head count. One of the problems with math is they try to, I don't know what you call it, hold the pinky up while they're talking. And that's why people don't understand it. All right, write down these three things. Okay, it says number one, there is a class width. Classes should have the same class width. In other words, 15 to 20. The next one needs to be the same width as 15 to 20. The classes should not overlap. If I have 15 to 20, I shouldn't have my next class being 20 to 25. It should be 21 to 25. No overlap. And each piece of data goes to one class. You can't have one class being in two sets of data, or one data being in two different classes. Now, here's two more definitions to go with that one. Lower class limits and upper class limits. These are on your classes. So if I got a, let me put this in perspective for you. Let's say that I go through and I get the ages of everybody in the class. There's my classes, and this is the number. No 0 to 4, no 5, no 0 here. Might have 1, 2 people here, 4 people here, and 6 people here. All right, there it is. Now, each time you have a class, there's two kinds of classes. There's qualitative data and there's quantitative. Quantitative is numbers. Qualitative is blonde, brunettes, and redheads. Blue eyes, brown eyes, green eyes. That's qualitative. Qualitative, with people wearing tennis shoes, boots, or flip-flops. That's qualitative data. All right? People wearing glasses versus people that don't wear glasses. That's qualitative data. But quantitative data, ages, weights, heights, shoe sizes. That's about it. Okay? So in this case, we've got quantitative data, which has a upper class limit and a what? Lower class limit, Hubert. That's right, class. Now, to find the class width, take your two class limits and subtract them. What's 5 minus 0? 5. So the class width for each of these is 5. Let's check it. What's 29 minus 4? 24. What's 25 minus 20? What's 20 minus 15? And so on. In other words, class width is 5. So to find the class width, then take your upper class limit minus the previous upper class limit, and that'll give you your class width. That's called a frequency distribution. There's a frequency distribution right here. Now, if you want to know the class width would be 363 minus 138. That would be class width. Your lower class limits are one on the left. Your upper class limits are the one on the right. This is your head count. If you want to know how many papers are being counted, you add them up, and that is N equal to N. This number down here is equal to the N, which is equal to what? Total. So to find the class width on this one, I just take 363. Somebody take a calculator and minus 138 from 363. What is the class width? So your class width is 225. Now, in probability and statistics later on in Math 120, you're going to find the mean and the standard deviation using class width and the midpoint and all that good stuff, but not right now. Question? This is a pretty boring part of the section because we aren't doing any math right now, so it's kind of boring. And in probability and statistics, you got to study, you got to read 2 chapters before you even get to the math. So that's why I'm going over all this stuff and you're not doing much math, because they just shrunk it down. Instead of 2 chapters, you got 2 little sections that you read instead of 2 chapters. So it's kind of shrunk out, left out a lot of stuff. Okay? This is the high points of the high points. They don't put a lot of low points in here. They just cover the high of the high. Okay? This is a histogram. Make sure you make a note of that, what a histogram looks like. The histogram is a bar chart where the bars are touching each other. A bar chart is a bar chart where the bars are not touching each other. So is the histogram and the bar chart the same thing? Yes. But you got to make the statisticians feel good. You got to give them their own little bar chart and call it a histogram. So just put that a histogram is a bar chart where the bars actually touch each other. Okay. I'm not going to ask you to construct a frequency. I'm not going to do that. I'm just asking you, I'm just hitting high points and we're not. That's a line graph and a bar chart. This is a line graph. Same thing as a bar chart, except it doesn't have the what? It doesn't have the bars. You just have dots and you connect the dots. I don't want to insult anybody's intelligence, but most of you should have picked that up somewhere in pre-algebra or algebra. Okay? It's not detrimental, but most of you that have had any kind of algebra or any kind of business math should have picked up by now that a bar chart and line chart is pretty much, one has lines that connect the dots, the other one has bars, and that's pretty much it. Okay? So that's the histogram and a bar chart. Histogram, bar chart, and a line chart. I'm not going to do a stem and leaf unless they give an example of one. I'll do it. But, yep. All right, stem and leaf. No, I'm not going to cover that. Circle graphs. These are important. This is a test question. Okay. I'm going to blow this one up a little bit so you can put it in your notes. Because you need to know, and this is also bar chart and line chart and histogram. Those are also standardized test questions. Along with this circle graph. It's also called a what? Anybody know what it's called? Yep, it's called a pie chart. Good job. Write that pie chart down, and I'm going to give you a number. And you need to make sure you know how to work that number. Okay? Let's say that this is going to write awfully weird because I've got it blown up so big. So it's going to be like huge. What if I tell you that let's say that my paycheck on paying for purchases, let's say that this is my budget. I'm just going to say my budget for, man, I don't work here. Okay, how I pay my bills. I pay my bills, and the way I pay my bills is I pay bills with 90% of my paycheck, and let's say that 90% of my paycheck comes out to be $900. All right. How much do I pay my bills in cash? Well, that would be 900 times what?
Okay, I'm sorry.
I pay my bills with $900. 40% of 900 is what I pay in cash. I pay my bills in cash. So somebody take 90% or 40% of 900. Well, 10%, that'd be 90 times 4, which would be 360. So $360 of my bills I pay with what? Cash. Well, how much do I pay with my debit card? Well, my debit card, I have to go through 3 or 4 debit cards because I run mine. I break mine. I spend so much money. I mean, not money that I have. Whenever I have money, I spend it. My debit card, I go through 2 a year or 2. It just falls apart. But anyway, debit card be 25% of 900. Well, 10% is 90, so it'd be 180 plus 45, be $225. So $225 I spend, I pay off my bills with debit cards. And let's say other or electronic. Well, 90%, 10% would be 90, 1% would be 9. 9 times 7 is what? 63. So $63 I use on electronic payments. And 18%, well, 10% is 90. And then 8 times 9 is what? 72. So that'd be $162 that I pay with credit cards. Y'all check me. What's 18% of 900? What did I say? 162? Whatever I said. I can't remember that. What did it come out to? 162? So 162 I pay with credit cards. So for the test question you need to be able to do, make sure you can tell the difference between a bar chart and histogram. The bars touch, the histogram don't. The histogram, the bars touch. Bar chart, they don't. Make sure you know what a line chart looks like. And make sure you know how to read a pie graph. Because those all 4 of those are standardized test questions. Now, like I said, right now, when you go and do 12.1 and 12.2 homework, you're only talking about reading type questions. You're not talking about a lot of math. So just be prepared. It's 12.1 and 12.2, not a lot of math. A lot of reading. There's another pie chart right there, example 9. That's 12.2. I think 12.3 is when we actually get into reading. And I think we're going to quit there for today. All right? So, let's look at your homework and make sure I got them both turned on because I don't want to go any further. I'm doing that out of being nice to y'all. 12.1 and 12.2. Because I want to take this easy because we're dealing with a different type of math here. And I don't want to get the cart before the horse. 12.1 and 12.2, I'll go ahead and assign. Okay, 12.1 and 12.2 are assigned. Now, 11.1 or 11.1 we already went over. Should be. I don't know. Whenever I put on there, I can't remember. 11.2 we don't cover. I mean right now. So you should be just working on 12.1 and 12.2. I'll check on the test. Let's see. There's 3 tests up, 4 tests. There they are. The graphing test is due on the 31st. And the 5th test, which is the Unit 3 test, which we're skipping over because y'all should be able to do it. It's not that hard. Is 5.3. So that's due on the, that's not right. Oh, it starts on the 11th. What the heck? That's not right. I'm sorry. That's not right. Hold on. Next. When's the last day of class? The 28th? Oh no, that starts. When did this? Okay, I'm just going to set it October 3rd. And it ends on the last day of finals, which is December 6th. Okay, now you should have all 4 tests. Yeah. That one's due on the 6th. This one's due on the 31st. And I think that's the only 2 tests y'all need to be working on right now. The Unit 4 test will be due whenever we finish both these sections. Okay, let me get the roll, and then I'm going to let y'all go for today. And I also know that y'all are coming off of that test. Some of y'all haven't finished the test yet for graphing. When is it due? Yeah, it's due Monday. So y'all got to work on that. So that's why I don't want to pile too much on you at one time. You're welcome. You're welcome. All right, Allie is not here. I didn't see her walk in. Bennett's here. Bradley's here. Carter's not here. Cromer, Edwards, Ellison, Erickson is not here. Gilliard is here. Jacobs, Littman, Mast is not here. Reed, not here. Scott, Smith, not here. Tucker and Wilkes. All right, y'all have a good day, good weekend. Work on that test and work on the homework. And read those first 2 chapters, 12.1 and 12.2. Mm-hmm.